Good day, guys. I've been here. Today, we're not going to talk about this because we did a similar exercise before. So just have a look. Basically, you can model in place some geometry and then apply wall by face or roof by face. And also, you can use other software like SketchUp. I think it's easier to do it that way. For this one, I'll just leave it here for now because there's a lot of stuff happening in this image, so I'm not sure which part you like me to talk about, so I'll just leave it for now. So and today we're going to talk about this one. So the most interesting part of this exercise is how to make this parametric. So how to create these so you can change the angle, adjust the the height of these points. So and also make everything parametric. You can adjust everything, but so these angles the most it will be hardest part. So I had a try. So this is the one I did with the green. I also did another one with the red. So they both work. So I'll do another one from scratch today. So okay, I'll just leave it there. So in case I forget how to do it again. So first, maybe I'll save this one. So I'll just save as a family. I just name it. Okay, I'll just leave it there, close it. Okay, so let's start a new one. So new, it will be a generic model because this is a request, can't be adaptive family, because if we use the adaptive family, it will be very easy. Okay, so generic model, just this one. Okay, so first we need to just let's have a look here. So I'm going to just do a screenshot. Just let's ignore that. So this is a family. So basically, this will be the reference plane. So this is a level. This is vertical, and so this is a point. So where this equipment fixed onto this. Let's say that's what's that? A post. Okay, so these are two points, fixing points, and also these two fixing points will be adjustable. So we're going to create two parameters for these 2 points, and then we will have so see here. So this is like I think it's kind of fixed. So basically, we are just going to create a little horizontal element there, but we're going to make this a parametric as well. So we're going to add another dimension parameter here for this part. So this is an interesting part. So we're going to have a little like arm, but we are going to make this simpler. So let's just do an arm, something like this, and we're going to make them same length. So of course you can make them different lengths, but let's just make it a little bit easier. So these two will be the same length, and then with this arm, so we're going to control this arm, so which means we can change the angle of this. So we're going to add a parameter to this. So this is the one of the parameter we're going to control this family, so this angle. Okay, and then we will have this one. So if I connect this point to this point, so this will be the length of this equipment. So we're going to basically have this length, and once we have that one, so it will be very simple, just do a sweep or whatever, like you can just based on that length and then create this element, or you can just nest another family into there. So so that's pretty much it. Very simple, right? Okay, so now let's go to Revit. So let's start first. Two fixing point. We need two reference plane. So okay, so dimension di. Oh, hang on. Sorry, just make sure. So this is floor plan. So that's not right. We need to go to. Let's go to left. Okay, so reference plane and the reference plane. So dimension di 1 and the 2. So this will be let's call it h1, and it will be a, let's call it let's make it type parameter, and this one will be a h2 and also type parameter. So type parameters, so usually we is for those like not change often. So basically in this family, I don't think we're going to change these two quite often. Not the length of this one, not the length of this, but the angle can be quite flexible. So we're going to make that instance parameter. So let's go back to Revit. Let's continue. So and every time when there's like a rotation in the family, so that means you will need to use reference line. Okay, so for this exercise, I'm going to do some circle to help me to help me. Okay, so reference line. So I'm going to do a circle here. So if I go back to here, so we can do a circle from here. So which means, so this is a circle. So see this arm. So this arm will always do probably not that part, but more about here. So from this to maybe horizontal, right? And then from that, let's do that circle from circle, and create a radius parameter. Let's call this one R1, and it will be type parameter. So and okay. And also, I want to lock this circle onto this to reference plane. So just check the center mark visible. Sorry, and the lock. Use align AL and lock onto this to reference plane. So with this one, so let's just create another reference line from this point to here, and also just make sure I'll select this reference line together with these two reference plane HI, and I want to lock this endpoint. So use AL and then tab and lock, tab, and make sure you lock the endpoint of this reference line. Type HR. So now we can add a dimension. Angular parameter. So DI. Angular, so from here to here. So this will be the angle we're going to use to control this family. So we're going to use instance parameter. Okay, so now, and then from this one, because we're going to so basically this is the send point of if another, so this is another arm from starting from here, so we can create another reference plane. So reference line circle, so from this point and do another circle. Okay, so create a radius and select this one, and we're going to just use the same R1, and so which means if I'm using the same same radius, because we're going to same arm length, so it will be the same radius, and so this is the point where this arm will be. Okay, so it's go up, go down. Okay, so now let me just try to change this one to maybe 30 degrees. So of course you can see it won't, so this circle won't follow, this reference line won't follow. So which means this is because we can't really lock anything onto anything here. So what we need is two reference plane. Okay, so we need to add two reference plane. So I'm going to just directly draw it from this point. Okay, so one and another one reference plane from here, and then because we have this angle here, so if I just do a screenshot here and connect this, so you will see this is a right angle triangle here, 90 degree. So we know that this angle, right? We know this angle, and also we know this is the radius R1. And from this and this A1, we can get the distance, the length of this one, and this one. So let's call this one x1. Okay, so x1, let's call this one y1. So in this right angle triangle, so we know that cosine A equals y1 divided by r1, sine A equals x1 divided by r1, which means x, so let's do y first. Y equals cosine A times r1. Okay, so x1 equals sine A times r1. So this will be the formula for x1 and r1. So go back here. So first we need to dimension di. So let's dimension this one. So this one will be y1, this one will be x1. So let's select this one, create a parameter. Let's call it x1, and it will be instance parameter. So this one, let's call it y1 instance, and okay. So now go to family types. In here, x1 equals, so let's go have a look again. X1 equals sine A times r1. So sine bracket A times r1. Okay. Sorry, that's not A. So A1. Okay, so now Control C, Control V, just change this sine to cosine. So and then if they are correct, so you can see this number become gray, and which means we are no longer able to adjust x1 and y1. So everything controlled by this angle. So you can see if I drag this one, Revit will tell me, you can't do this. Okay, so we need to adjust this angle. So when I change this, you can see these two reference plane will change accordingly. Okay, so now with these two reference plane, we can lock this circle and also this reference line onto these two reference plane. So let's do it. So I'll select these two reference plane and this reference line and this circle, type HI. So first I'll just select this one, turn on the center mark and use AL, align, and lock. Hang on, what's this one? I'm not sure. Let me just cancel this one for now. Maybe I'll just move them onto this point first. I'll try to onto this. Okay, great. AL align, AL align, and center mark. Great. So now I'm going to HH this circle. AL align, tab, lock, tab, and lock. Type HR. So now we have this. And then we still need to, let me, hang on, what's next? Okay, I think this is first part. Now the next part is let's just do the little fixing point here. So we add a vertical reference plane. So let me maybe just roughly type in 200 here. So this one will be the vertical, the horizontal part. So this one, let's call it fixed. So basically it's a fixed point. Okay, so now if we hang on, let me think. If we create a reference line from this point to okay, because not sure yet, because it can be here, but it can be here as well. So imagine so this the the arm, it can go up, can come down, right? So you can go all the way up to here, depending on the length of. But this length will be the length of the equipment, so it shouldn't change freely like this arm. So we're going to do the same thing. Create a let me just do a circle from this point, go up. So I'll just roughly, just for example here. So and then this radius will be the length of this equipment, and where this one intersect with this circle will be the point where this arm. So if I drag this one to here, so where this arm connects to that equipment. Okay. So now let's add another parameter. So we have R1. So this one, let's call it R2. Okay, so it will be a type because we don't want to change it like we're changing the angles. Okay, so now we just need to create a reference line from this point up to here, and then we need to work out how can we control this reference line. So every time we move the angle, or it will always you know, touch always you match this this arm. Okay, so this can be a little bit, oh hang on, let me just forgot to do this one. So we have x1, so let's call this one x2. Okay, so x2 type. Okay, so let's have a look. Okay, we need to do this. So we need to create a reference line from this point to this point. And okay, so let me just do a screenshot. Okay, so if I connect this point, connect this one, and connect this one, so this is not a right angle, but in this triangle we know all the length of this. Okay, so this one is R1. Okay, so see here, same R1. This one's R2. Okay, and what's this one? So we can calculate this one. So if I draw a line up here, create this right angle triangle, we know that this is x1 minus x2. Okay, so this is x1 minus x2, and we know this is y1 plus h2 and then minus h1. Okay, so this is this, and then we can get, we need this one, right? So we need this. So this is square root of, you know, this square, so x1 minus x2 bracket square plus this one, so y1 plus h2 minus h2 bracket square. So we can get this one. So once we have all the three length in this triangle, so we can use the formula. Sorry, I can't remember the name of the formula. It's a cosine. So it's basically angle. So we need to create an angle parameter. Let's call this one, we have A1. Let's call it A2. So basically cosine A2 equals R2 square. Let's call this one, maybe let's call this one, because this is very long, right? So let's call it maybe B. Okay, so plus B, oh hang on, let's use lowercase b, because we use capital, that doesn't matter, let's call it B. Okay, plus B square minus C square. So sorry, this one, R1 square divided by 2 times, let me think, 2 times R2 times B. Okay, so this will be the formula. So which means A2 equals A cosine everything here. So this will be the formula for the A. Once we have A, we can control this the angle of this equipment, the length of the equipment. Okay, so so let's go back to Revit. I'll just move this to my other screen so I can just follow that. Maybe I'll just leave it for here for a few seconds, so you can pause if you want to write this down. Okay, I'll just move it to the other screen. Now, here, first we need to work out the length of this one. So I'm going to create a parameter. Let's call it b, lowercase b, and it will be a instance parameter. Okay, and the b equals sqrt square root of bracket, another bracket, so x1 minus x2 bracket square plus bracket y1 plus h2 minus something's not right, y1 plus h2 minus h1. Yeah, I think I did it wrong. Minus h1. Okay, so that's all good. Bracket and square and another bracket. So let's try. Okay, so good. Click OK. So I'll just drag this back for a few seconds. So this one's h1, so not h2. Okay, so good. Now we need to do the cosine A. So first you do a dimension di angular. So let's call it A2 instance and OK. So the formula will be go to family types, A2 equals arc cosine. It's the same. You can use lowercase or capital. Arc cosine bracket. Let's just add another bracket. R2 square plus lowercase b square minus r1 square bracket divide by bracket 2 times r2 times lowercase b and another bracket. I think this should work. So yeah, yeah, it works. So, and also you can see if you do it correctly, the number will stay the same, because when we draw, we just make it exactly where it needs to be. And if the formula is correct, you can see the number stay the same but become gray. So apply, okay, and so let me just move this back again, so you can just have another look. Okay, so this is how we get all the formula. Okay, so now let's have a test. So how do we test? So so this is the angle, so let's try 45 degree. Okay, so looks like something's still not right. So you can see this one's just go up, this one's go to the left. So Control Z. So this is because we didn't constrain them properly. So let's select this one. So because this one go to the left, so what we need to do is Control select the reference plane together with this reference line HI. Now we AL align, tab, lock. So not this direction, so the other direction. So this lock. Okay. Oh, something's not right. Maybe it's not because of this. Maybe it's this. Okay, so let's try this. Oh, hang on. Maybe do this. So VV. So just turn on the sketch dimension and see. Okay, so we have here. So okay, that's good. Let's try select this one. Yeah, select this one, and this reference plane, HI. Let's lock, and also this tab lock. So HR still there. So probably it's because this one as well. So once again, select the reference plane and this reference line, HI, AL, tab lock. Not this. This tab lock. Okay, good. HR. Still something's not constrained there. I'm not sure. Not this one. Not this one. HH. This one. Oh. So it looks like that's the circle. Okay, so turn on the center mark, and now AL, lock this. Yeah, so that's great. So no longer the blue dimensions. And there's one here. So let's type HR. So I think it's probably this one, not this one, this one. Yes. So you can see when you select the element, if this temporary dimensions associated to that element, it will change the size of it. Okay. So now let's select this one. Oh, hang on. How can we? So this is not locked because there's nothing we can lock onto, but we can do the same thing. So you can see this because we know the length of these three reference line, and we can work out the angle. So if we can work out the angle, we can get rid of this dimension. So let's add another dimension, di, angular. So these two, select this one, let's call it A3, and instance, and OK. So now we just need to go to the family types. So A3 will be very similar to A2. We just need to copy this and just change some parameter. So from these two, so we still use into this one. So we still need this lowercase b, but we change the R2 to R1, okay, and change R2 to R1, and change R1 to R2. So now this, yeah, so you can see the angle stay the same, but become gray. So which means that's correct. So now you can see it's get rid of all the blue dimension, the temporary dimension. So I think that's all good. So now let's have another test. 30 degree. Okay, it's still not right. Okay, so there's another one here. So let me just try to lock this one onto this. Yeah, it's not this one. Not this one. Yeah, this can. Okay, let me think. So this should be locked onto that, but it's not. Yeah, I'm not sure. Give me a few seconds. I'll try to work it out. Okay, I'm back. Very interesting. Once I click on here, so to be honest, sometimes these are just not sure how these work, but yeah, sometimes this will make difference. So I just click on lock, and because all these parameters are linked to each other because we have all the formulas. So once you click on one, it will click all of them. So once we lock them, so it will work perfectly. Oops, let me try to change it. So see, once it's locked, and then it will work. And now you can see, I think we don't need, because the reason why I draw this circle is because it helps me to like visualize this, so you can see this is a circle, and then make sure that looks right. But I think we can probably just delete these circles. We don't really need them, so I'll just delete them and have another test. So okay, so this is very much simpler now. So I'll just do another test and see what happens now. Okay, so it's like it's still working, right? Although we don't really know, it looks like okay, but this one looks still okay, but it's a little bit harder to tell whether it's correct or not, but it looks like it's okay. So yeah, so this is it. So now it's looks like very simple, right? So okay, so this is a structure. So this is a skeleton of this family. And the next thing is, I think it will be very simple. You can just place everything, just model things. So for example, I'll just quickly do some model. So we can do this in 3D view. I'll change the scale. Yeah, so I'll just do a very quick sweep and use pick path. So this will be the arm. I'll just do a a little shape, and okay, so that's the arm, and then for the element, so one method is you can just model. Oh, hang on, not sketch path. Did I just use sketch path? Pick path. Another method is you can model the equipment and nest that into this family. So that's another way. But for this, I'll just do a very simple, not big enough, just make it bigger and finish. Okay, so that's the equipment. Oh, what's this one? This can't remember. Something we use to help us to make it work. And yeah, so maybe let's go to floor plan. We can also have a little structure there. So I'll just do extrusion there. Oh, why use blend? Sorry, extrusion, something like that. Go up. Okay, so that's it, right? So now let's try to adjust. So the main parameter to adjust this is this family is this angle. So this change the angle of this one. Okay, and 30. And then you can adjust the point of this, the base point, which is H1. So if I increase this one, you will see it will change the angle of this one, but keep the angle of this. For example, I'll just type 300, it will go up. So you can see that the angle of this will change, but not this part. If I change, let's say, reduce the size of this one. So the equipment, which is R2, I believe. R2, so I'll make it shorter. So this will change the angle of this one, right? And what else? R1, what's R1? R1 is the length of this, so both. So if I change this one to 500, so you will see, yeah. So everything works, I think. H2 is this point. And type, let's try to change this one, make it higher. So 1800. Yeah, so it will change the angle. So to match this, to make sure that the length of this equipment stay the same. H2, oh sorry, X2. What's X2? X2 is this point. So make it like. How about we make it? Oh, great. 900. Trying to break it. Yeah. So at some point we will break this family, but yeah, just if you did it properly, I think it won't break easily. But yeah, I think everything works. 30 degree. How about 90 degree? Great. And that's it. Let's lower this point. H1 100. Lower this one. Yeah. So this is a family. Let's make this 50 maybe. And we still need to model that bit, but I'll just leave it for now. So this is it. And have a, I'll upload this family so you can have a play. If you find a better, so of course adaptive family will be easier, but in generic model, if you find a better solution, easier way, please let me know, because trigonometry is always, very quite confusing, right? So thanks for watching, and I'll see you next time. Thank you. Bye.